Hello, my name is Elma Maliqati and I'm presenting a topic for 3-minute science competition. My topic is the Seven Bridges of Königsberg. The Seven Bridges of Königsberg is a historically notable problem in mathematics. Its negative resolution by Leonhard Euler in 1736 laid the foundations of graph theory and prefigured the idea of topology. The city in Königsberg in Prussia, now Kaliningrad in Russia, was set on both sides of the Prejel River and included two large islands, which were connected to each other by 7 bridges. The problem is, can you take a walk through the town, visiting each part of the town and crossing each bridge only once? The map of the bridges can be simplified further by sketching it as given in the screen and by labeling the land areas and bridges. The challenge is, can you draw each line without removing your pencil from the paper, as you may start at any point? Let's guess for some simpler shapes. How can we know which ones work and which ones do not? Let's investigate. Firstly, it's time to learn some special words. A point is called a vertex, a line is called an edge, the whole diagram is called a graph. Yes, it's called a graph, but not the kind of the graph given in the right. They are both called graphs, but they are different things, just how it is. The number of edges that lead to a vertex is called a degree. The vertex given in this picture is intersected by 3 edges, that's why it has degree 3. A route around a graph that visits every vertex once is called a simple path. A route around a graph that visits every edge once is called an Euler path. Okay, imagine the lines are bridges. If you cross them once, you have solved the puzzle, so what we want is an Euler path. And here's a clue to help you. We can tell which graphs have an Euler path by counting how many vertices have an odd degree. The number of vertices of odd degree must be either 0 or 2. If not, there is no Euler path. And if there are 2 vertices with odd degree, then they are the starting and ending vertices. Here we have the reasons for that. A path leads into a vertex by one edge and out by a second edge. So the edges should come in pairs. That means we have an even number. Only the start and end point can have an odd degree. Back to the Königsberg Bridge question. In this picture, vertices A, B and D have degree 3 and vertex C has degree 5. So this graph has 4 vertices of odd degree, so it does not have an Euler path. Therefore, we have solved the Königsberg Bridge question, just like Euler did nearly 300 years ago. Thank you for your attention.